So a couple days ago, I was thinking spaghetti. Then I realized I couldn't make a science video on it, so then I thought, hey, I'll make a video on why our ears hurt underwater. Well, the first thing to consider is that water is heavy. It has weight, just like you, me, or a plate of spaghetti. And because water is a liquid, this means that its weight presses evenly on anything surrounding or inside of it. So like for instance, water presses evenly on the surroundings of this container full of some sort of liquid. It presses on the sides evenly. So that's a very important thing to know because this includes your eardrums when you're underwater. So this is a bowl of water and this is you. The weight of water applies a force to every area of your body, and we can figure out how much force by measuring the pressure at those depths. The pressure exerted by the water can be measured in units known as pascals, which is equivalent to 1 Newton of force per square meter. This measurement can be calculated using math. The pressure exerted on objects underwater on Earth is equal to the acceleration of gravity times the density of water times your depth underwater. And because the acceleration of gravity is equal to 9.8 meters per second squared, and the density of water is equal to 1,000 kilograms per cubic meter, this means the pressure exerted by water at a given depth is equal to 9,800 times your depth underwater in meters. Or if you want to use PSI for pressure, so pounds per square inch for pressure, and feet for depth, then you multiply the number of feet by 0.445 to get the pressure in PSI. Fun fact! Because we know that regular atmospheric pressure is 101,000 pascals, or 14.7 pounds per square inch, this means that if all the air was sucked out of your lungs, the atmosphere would put as much pressure on your lungs as if you were at the bottom of a 31-foot deep swimming pool. Now you might be wondering, why can I plug my nose and blow out and make my ears pop? I don't know. Just kidding. This is because the air on the inside of your eardrum is connected to your nose by the eustachian tube. This tube is there to keep the air pressure on both sides of your ear equal so that they don't hurt or stop working just because you went up a mountain. However, when you go underwater, water presses on the outside of your eardrum, but water does not press on the inside of your eardrum. So it applies a force on the outside, causing it to stretch and hurt. So yeah, that's basically it. So if you liked this video, be sure to like this video. And if you want to subscribe, then be sure to smash that subscribe.